So I asked Claude Code to do deep research on a topic, and I expected it to just go search the web for a while. That's not what happened. Instead, it wrote a JavaScript file, a full workflow, about 400 lines of code generated on the spot just for my request. And that file wasn't the research. It was a runtime. When it ran, it spawned over 100 separate agents, each with its own context window and its own system prompt, all working through my question in phases. And here's the part that got me. If I send a different research request tomorrow, Claude Code writes a completely different workflow file, different structure, different number of agents. Nothing is fixed. The whole thing gets designed fresh every single time. That pattern has a name now, and for the past few weeks, it's been everywhere. People are calling it graph engineering. And I want to walk through what it actually is, where the idea comes from, why the timeline exploded over it in July, and whether it's a real shift or just a new sticker on something we've had for years. Because honestly, both sides have a point, and by the end of this, you'll be able to judge it yourself. The word graph here has nothing to do with charts. It comes from graph theory, and that goes back to 1736. There was a city called Königsberg with 2 islands, 2 riverbanks, and 7 bridges connecting everything. People in town had this puzzle about whether you could take a walk that crossed every bridge exactly once. A mathematician named Euler looked at it and did something clever. He ignored the city entirely. He drew each piece of land as a dot and each bridge as a line between dots. Dots and lines, nodes and edges. That's a graph. And once the problem looked like that, he could prove the walk was impossible because too many nodes had an odd number of edges touching them. The proof itself doesn't matter for us. What matters is the move. He took a messy real-world thing and reduced it to nodes and connections, and suddenly it became something you could reason about. Now take that lens and point it at my deep research run. My workflow had 5 phases. 1 agent scoped the request and broke it into subtopics. Then 5 agents went out to find credible sources, 1 per subtopic. Then 25 agents fetched and extracted the actual content. Then around 75 agents did verification, basically fact-checking claims and voting on which sources to trust. And 1 final agent took everything and wrote the report. Each agent is a node. Each handoff between them is an edge. And since the work only flows in one direction, left to right, with nothing ever circling back, this specific shape is called a DAG, a directed acyclic graph. Directed because edges have a direction, acyclic because there are no loops. You could run that entire job with 1 agent instead. It would work. It would also be painful. The time cost alone is brutal because a single agent reads 1 source at a time while 25 parallel agents read 25 at once. But the deeper problem is context. A single agent doing everything has to hold the plan, the raw sources, the partial summaries, and the draft report all in the same context window, and it ends up compressing and summarizing its own memory over and over just to keep going. Quality degrades quietly when that happens. In the graph version, each agent holds only its own little job. The verification agent checking claim number 40 doesn't know or care about the other 74 claims. Its context stays clean. There is a real cost, though, and it's tokens. Anthropic publish numbers on their own multi-agent research system, and a single agent conversation already burns about 4 times the tokens of a normal chat. A multi-agent system burns about 15 times. On my run, each of those 108 agents started with roughly 20,000 tokens of context. On Opus 5 pricing, the raw input cost would land near $10 per research request. Prompt caching pulls that down to around $1 in practice, since most of that context is shared and reused. Still, that's the trade. You're spending tokens to buy time and quality. Okay, so why is everyone suddenly talking about this in mid-2026 when none of the underlying ideas are new? And I mean genuinely not new. Microsoft AutoGen had agents talking to agents back in 2023. LangChain built LangGraph around the same era, a whole framework for wiring agents into graphs, and it's now pulling over 65 million downloads a month. Anthropic themselves published 5 workflow patterns back in late 2024. Prompt chaining, routing, parallelization, orchestrator workers, and evaluator optimizer. Every one of those is just a graph shape with a friendlier name. The spark this time was a single post. On July 18th, Peter Steinberger, the guy behind OpenClaw, posted one line on X asking if we're still talking loops or if we've shifted to graphs yet. That post pulled over 500,000 views within hours. About 4.5 hours later, Hamel Hussein published an article literally titled "Loop Engineering is Dead," and within 2 days, the term graph engineering had a manifesto, a backlash, competing definitions, and people calling the whole thing slop. An Anthropic engineer added fuel with the talk, claiming that in 4 to 6 months, everyone will be orchestrating self-improving agents through graphs and prompts, will basically be a legacy skill. Quick context on loops, because that's the layer right underneath this. Loop engineering was the thing everyone obsessed over from late 2025 through this June. The idea is you stop prompting an agent turn by turn and instead design a cycle. The agent acts, checks its own result against some verifier, retries, and keeps going until a stop condition is met. Tools made this a first-class feature. Claude Code, Codex, and Hermes all shipped goal commands this spring that turn a whole loop into one instruction. Prompt engineering controlled one model response. Loop engineering controls one agent's full behavior cycle. And graph engineering, if we take the term seriously, controls how many of those loops connect to each other. It's a stack, not a replacement. Each layer sits on top of the one below it. LangChain's response to all the hype is worth reading, because they've been shipping this for 3 years, and their take was basically that nothing changed about graphs. What changed is what a node can do. Back in 2023, a node in your graph was just a raw model call. You'd chain a few of those together and get something fragile that broke constantly. Today, a node can be an entire coding agent with tools, file access, terminal access, and its own inner loop. The nodes got good, and once the nodes got good, the bottleneck moved. It's no longer about making one agent smarter. It's about the edges, the structure, how you split a task across agents and wire the results back together. They also pushed back on one detail that I think matters a lot. Real production agent graphs are usually not DAGs. My deep research example was clean and one-directional, but actual working systems need cycles. An agent retries a failed tool call. A validator rejects an output and sends it back upstream. An agent pauses to ask a human for missing info and then resumes. All of those are loops inside the graph, edges pointing backwards. So the tidy left-to-right diagram is the demo version. The production version has arrows going both ways, and honestly, a loop is just the smallest possible cyclic graph anyway. The two concepts were never really separate. One more framing from this discussion that stuck with me. Serious multi-agent systems actually run two graphs at the same time. There's the org graph, which is stable. These are your long-lived agents with named roles, each owning a domain, accumulating context over time, kind of like job descriptions. That graph only changes when you redeploy. Then there's the work graph, which is ephemeral. It gets generated per task, exists only while the work exists, and gets thrown away after. That 400-line JavaScript file Claude Code wrote for my research was a work graph. It lived for a few minutes and died. The org graph answers who does what in general. The work graph answers what's happening right now. And I'll be honest about the skeptic case because it's fair. Most tasks do not need any of this. If you're fixing a bug or writing a function, a single agent in a single loop is faster, cheaper, and easier to debug. Spinning up a 100-agent graph for that would be a waste of money and a nightmare to trace when something breaks. The people mocking graph engineering as a buzzword are right that the vocabulary is new while the technology isn't. But the people taking it seriously are right about something too. Tasks like deep research, large migrations, or multi-source verification genuinely do outgrow one context window, and at that point, structure stops being optional. So here's how I'd frame the whole thing. Euler's contribution wasn't solving a bridge puzzle. It was showing that once you reduce a problem to nodes and edges, you can prove things about it. Our version of that same move is figuring out how to carve a big task into pieces that individual agents can own, and then designing the connections between them. Prompts still exist inside every node. Loops still run inside every node. The graph is just a layer that decides how it all fits together. Whether the name sticks or not, that layer is where the interesting engineering problems live right now. And judging by how fast tools are generating these workflows on the fly, we're going to be designing a lot fewer prompts and a lot more structures.